Today is July 5th, 2015. Here's another talk for everybody. Now, keep an open mind when you read this stuff. Don't think that what I'm saying is like fact, because it's nowhere near fact. It's just completely hypothetical, completely out there in outer space stuff, okay? But one thing I noticed is the assumption of the consistency of Earth's atmosphere. I got this idea from Fred Hoyle's book called Astronomy. The root assumption of geophysics and astrophysics in this regard is that the Earth's atmosphere was consistently the same size and composition for hundreds of millions of years for the most part. In other words, right after the Earth formed, the atmosphere remained the same size, the oceans remained the same size, everything was just as we see it for hundreds of millions of years. Now, I don't know about you, but I think that's one hell of an assumption to make, being that we see objects that are very different than the Earth out there. And I'll go over that in the second part of this talk. The correction with stellar metamorphosis is that Earth's atmosphere was not consistently the same size or composition. This to me is obvious. As the Earth evolved, the atmosphere will dissipate and has dissipated considerably over many, many hundreds of millions of years as per the establishment's assumption. Now, what we have here is a realization that the central regions of evolved stars, such as Neptune and Uranus, actually have Earth-like cores in them, which are not as large as the Earth, obviously. They're a bit smaller. A lot of the material hasn't deposited onto the surface yet, and a lot of the compositions of the chemicals have not gotten to that point to where they can form rocks and minerals as effectively as late-stage stars, such as GJ 1214 Bravo. Now, this part is mostly hypothetical, but this is definitely a realization of the Earth's history and the fact that it's much richer than what establishment has it being. This is obviously the back half of cell evolution before the star could even radiate in the visible spectrum, but I will make a video reviewing that again as well. Now, the evolution of the atmosphere has the Earth being rocky in the center and supercritical matter taking up a large region around the rocky interior, and then you have your liquids, and then you have your gases in the very outside regions. This is the stage in which early amino acids are formed. I believe that the amino acids, a lot of them, are formed in the interior, as well as with photochemical reactions in the outer atmosphere. Photochemical reactions are very, 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 very important because they contain ultraviolet light, which can mix up chemicals and do weird things with it, which then would fall into the interior, get hot, and switch over again to some other process, forming a lot of different kinds of chemical compounds. Over time, the atmosphere dissipates, and the interior comes out, and the material changes size and composition to where the supercritical matter is not as abundant, the liquids are not as abundant, neither are the gases. This is where early life begins to form as well. There's some kind of feedback loop in there with life formation that I really haven't gone that much into, but hopefully one day I will be able to. And over time, the star continues evolving, photo-evaporating away, getting hit with meteorites, getting hit with asteroids, adopting moons, which then maybe skim the surface and create rings around the star. But anyways, you go down here, a lot of material is ripped away. No land is exposed yet. That's very important, being that this is a water world. It has a very thick atmosphere. It has very thick water interior, which a lot of it is supercritical around the rocky surface, which is still more like liquid hot magma, but this is the part where life evolves. And the major area where dinosaurs lived, or when dinosaurs lived, where a lot of very ancient animals lived, was in this area right here, between this stage and this stage. And the most important part I want people to know is that the Earth was at one point a water world. So it means if we're going to find really, really ancient creatures, chances are more than likely that they're not going to be creatures that were reliant on the sun for heat. The heat would be reliant, or the heat would be on the interior of it. So basically, this object can wander around wherever it wants in the galaxy and still host life. There's no need for it to be around a sun-like star. Same with this, same with this. These are independent constructs. They don't need to revolve around a hotter star to keep liquid material in its interior, because the core is still hot and it can melt all this stuff, keeping the interior supercritical. So there's that. As well, the individual stages between that and the Earth the way it is now results in the atmosphere thinning considerably and the oceans thinning, and there being a land beginning to be exposed to where creatures can start then, walking around on the land. So there you have it. There's a really magical part in here that I need to overview in the future, but a lot of that is hypothetical, and if anybody wants to do the research on their own, look up the aquatic dinosaur theory. I can't remember what the gentleman's name was, but he believed that dinosaurs lived in a more of an aquatic environment than what establishment says, which would explain why they were so big, because they lived in essentially a quasi-water world in between this world and this world, to where there was more water on the surface. All right. I think that sums it up. If you have any questions or comments, please leave them below.